Okay, this PowerPoint is going to be on similar polygons. What is a similar polygon? When a polygon has the same shape but may be different sizes. This is important. Two polygons are similar if and only if their corresponding angles are congruent and their corresponding sides are proportional. So each corresponding angle is congruent as shown in the picture. So this angle is congruent to this angle is congruent to that angle, and so on. And each corresponding side is proportional, which means 5/10 equals 2/4 equals 3/6 equals 1/2. So we take 5/10 because those two sides are corresponding, 2/4 because those two sides are corresponding, and so on. If you reduce the ratios created by the corresponding sides, they should each equal the same thing. In this case, they all reduce to 1/2. Example 1. Determine whether the pair of rectangles is similar. Step 1. Are all corresponding angles congruent? Yes, all rectangles have 4 right angles, so all corresponding angles are 90 degrees. Step 2. Are all corresponding sides proportional? Since in a rectangle we have 2 pairs of congruent sides, we just have to check one of each. So we have side 1, which is 12/10 equals 2, and side 2, which is 24/20 equals 2. Since the corresponding angles are congruent and the corresponding sides are proportional, then the two rectangles are similar. What is the scale factor? The ratio of the corresponding sides between similar figures. Example: the height of the Soldiers' National Monument in Gettysburg is 60 feet. The height of a model is 10 inches. What is the scale factor of the model compared to the original? Step 1. We change feet to inches because you must have the same unit of measure. So 60 feet times 12 inches, because there's 12 inches in a foot, equals 720 inches. Step 2. We set up a proportion. So we have the height of the model over the height of the monument. So that equals 10 inches, which is the height of the model, over 720 inches, which is what we found to be the height of the monument. And that reduces to 1/72, which is your scale factor. Example 2. Write a similarity statement, then find A and the scale factor of triangle JKL to triangle XYZ. So we have step 1. We have our similarity statement. It is important to make sure that the vertices are corresponding. So triangle JKL is similar to triangle XYZ because J matches up with X, K matches up with Y, and L matches up with Z. Step 2. We find A, so we set up a proportion. So 3 divided by 2 equals A over 1.5. So we have our corresponding sides, 3 divided by 2 and A divided by 1.5. And then we cross multiply and we find that A equals 2.25 inches. If you can't remember how to cross multiply, then you should look at the proportions PowerPoint. Step 3. We find the scale factor. So triangle JKL divided by triangle XYZ equals 3/2 equals 2.25, which is what we found A to be, over 1.5, and that all equals 1.5, which is your scale factor. Example 3. Triangle ABC is similar to triangle XYZ with a scale factor of 2 over 3. It is the sides of triangle ABC are 6, 8, and 10 inches, which are the lengths of the sides of triangle XYZ. Step 1, we set up proportions. So triangle ABC over triangle XYZ equals 6 over X equals 2/3. Triangle ABC over triangle XYZ equals 8 over Y equals 2/3. And triangle ABC over triangle XYZ equals 10 over Z equals 2/3. So what we did is we took each side length of ABC right here. We put 6 over X because that's what we're trying to find. And then we have our scale factor 2/3. Same for here and same for here. Step 2. Solve for X, Y, and Z. So we cross multiply, so we get 2x equals 6 times 3, 2y equals 8 times 3, and 2z equals 10 times 3. So then we get x equals 9, y equals 12, and z equals 15. Step 3, the answer. The side lengths of triangle XYZ are 9, 12, and 15 inches. If you have any problems, you can come to my office hours or you can contact me on the contact page of the website.